Okay, thanks everybody. Thanks for having me the presentation today. Uh, Give me just 1 second here. All right, thanks for having me today. Thanks to the organizers for having me as part of this presentation. So what I wanted to talk today about is building consumer internet products with data science. As you heard, I've had quite a journey. I started out at 23andMe as a research scientist, and then joined a number of educational technology companies. First Coursera, and then Udemy. And as part of this journey, I've had to kind of transition outside of the world of academia into really understanding what it's like to build a consumer internet product. And so what I wanted to do today was share some of those learnings about building consumer internet products with all of you. Okay, these are some of the lessons I've learned that you realize once you're in industry, they don't really teach you in school. So to begin with, let me just talk a bit about what really makes a data scientist in our industry. Okay, so if you look at advice around how should you craft your career as a data scientist, one very common piece of advice that you'll often see from many people is the idea of being a T-shaped data scientist. So what does that mean? A T-shaped data scientist is a data scientist who has both breadth of skill as well as depth of skill. So breadth of skill means that there are a broad number of technical and non-technical skills that you have across a variety of areas that provide you that common base to communicate with a wide variety of audiences. But depth of skill means also having an area of expertise. That might be economics, it might be computer science, could be a number of different things. The reason that T-shaped data scientists are so useful is that the way that data science teams are constructed is that data science teams typically optimize for diversity of talent. It's impossible to have an individual who knows everything about economics, deep learning, statistical physics, clinical trials, operations, research all at once. So instead of hiring individuals who know everything, typically data science teams will build groups that collectively have all of these types of talents, right? Now, when it comes to how companies hire, there are different types of data scientists. There are those who are more generalists, and then there are those who are specialists. The generalists tend to focus on higher level concepts like metrics, ad hoc analysis, data visualization, A/B testing, and this is what we call often analytics in the industry, right? At Udemy in particular, we have a data science track that we call the Insights data science track. This focuses on operational strategic decision making using product and marketing analytics. However, you also have roles that involve a much greater degree of specialization. So for instance, many times people will be interested in causal inference, simulation, forecasting, building complex models to really understand and predict human behavior. So this requires a much more in-depth technical skill set. On the other side, you might have folks who are actually building products, not just trying to understand how the world works, but implement this in some sort of technical system. And here you have folks who are machine learning engineers, algorithms people, right? So these folks work alongside engineers to build ML-powered data products like personalized recommendations. So this is the sort of the landscape of data science roles that exist within companies. And in order to really unpack, what it takes, one of the ways of thinking about this is a famous diagram created by Drew Conway that shows the data science Venn diagram. It's really the set of skills that you need in order to become successful at data science. On the one side, you have hacking skills. These are your programming skills needed in order to implement solutions. But there's also math and statistics knowledge. These are the technical skills that everybody knows about. Now, every data scientist, however, really needs more than just technical skills. They need substantive expertise that allows them to be proficient in really working with a business, working with a product. And so what I'm going to talk about today is what is the nature of this substantive expertise, specifically for consumer internet companies. So if you're working in a consumer internet company, what is the substantive expertise that you need in order to be successful? For me, it really kind of boils down to a number of things. One, partly it's about what I call product sense, and I'll get into what this means. Also, it's about analytics skills, having a toolkit of standard methods that are useful for analyzing consumer data. And then third, it's about having maybe domain knowledge relevant to the company that you're joining, the communication skills needed to work effectively with individuals throughout the company, and also maybe like business sense in order to understand how your work can ladder up to the goals of the company overall. I'm going to actually ignore that third arm because that third arm is kind of very common to a lot of different companies across a lot of different industries. But I will focus primarily in this talk on product sense as it applies to consumer internet product companies, as well as product analytics skills. Okay, so let's talk about product sense. So, what is product sense really, and how do you develop? So, product sense really starts with identifying customer problems. At the core, it's about understanding who your customer is, what they're trying to accomplish, and how those needs are met today. So one of the things that's often very tricky, if you're entering a consumer internet company for the first time, if you come from a technical background, you're kind of wondering, what is this mystical product sense that people are talking about? The way this actually translates in practice is that um, understanding customers is really about trying to figure out who are the different types of customers, the different segments, or even personas that you might be addressing. Whether in the case of Udemy, for example, we have professional learners. We have folks who come in who might actually already be in school today. Maybe they're academic learners, for instance. These are different types of segments that we might want to address. Furthermore, we need to understand, what are these individuals trying to accomplish, right? Like we want to understand, are they actually trying to get a job? Are they just trying to just simply be enriched through courses, right? And finally, we need to understand how their needs are met today. We really need to understand what it is that they're using in order to accomplish some of these needs. Are they thinking of Udemy as a substitute for textbooks? Or are they thinking about it as a route to, perhaps advancing in their career today, right? So these are the types of questions that we care about with product sense. Product design really focuses on solving customer problems. And so once we have a sense of what it is that customers need, we really want to understand then, how do customers actually interact with our product? So for a data scientist coming into consumer internet products for the first time, often what I have actually found myself is when I first thought about product design, I thought it was really mostly about visual design. Thought it was about how do you lay out things on a page. But product design is really more than that. It's really about understanding, how does your product actually solve for customer problems, right? So key questions that you need to understand include understanding how people interact with the product, how do they think the product is going to be used, and is the product really successful in solving customer problems? So for instance, when you're thinking about a flow from one page to another page, the key question is the customer behaving in the way that you expect? Or is the customer simply navigating on your website simply because they're confused about what's going on, right? Finally, there's this notion of product intuition overall, product sense. So putting all these things together, I would say product sense is the ability to identify customers' needs, design potential solutions to address these needs, and then to analyze how well a solution will work for a customer. So if you're transitioning into a consumer internet product company and you're thinking about, what is it going to take to get the job, how can you appropriately interview, you'll really need to combine all these things, right? Now, for many data scientists, this is a big challenge because we're often used to thinking about solving technical problems. Sometimes these problems may be well posed, et cetera. But you can develop your product intuition and product sense over time. And the way you can do it is by analyzing existing products, asking for existing products, what exactly are the customer needs? How does this product attempt to address those customer needs? And how well does that product work? Discussing with other people is often a great way to hone your ability in this area. So the next piece is, aside from product sense, a key element is also having the product analytics skills necessary to know how people use data in order to understand consumer behavior. So there are a variety of different topics in this. And what I'm going to do is I'm going to provide a survey of some of these things that might be useful for you to know. So first of all, there's the idea of estimation, right? So if you're working on a product, oftentimes you want to understand, what are the right problems to be solving? Estimation is critical for sizing potential opportunities. And a very common strategy is something that's known as Fermi decomposition, which is really taking a quantity that you don't know, breaking it down into a combination of simpler, easier to estimate quantities. So for example, if you're interested in introducing, some new product line, or you might try to estimate the number of units sold by multiplying the number of target customers by the amount of market penetration that you think you can achieve and multiplying that by the order size, right, for each customer who decides to purchase. The process of decomposition, taking a simple quantity and breaking it down into smaller quantities, the reason it helps is that the more you break things down, the more opportunity there is for all the errors to cancel out, right? Assuming that these errors are independent from each other, hopefully they'll cancel out, and then you'll end up with some overall more reliable estimate. But part of the problem with framework decomposition as well is, like, the more you the more complex your model becomes, actually the harder it is to reason about your system as a whole. So you have to be a little bit careful about how you approach this. So estimation is one key technique that you might use. Another thing that you need to consider when thinking about building consumer internet products is often many product teams will be interested in understanding what the North Star metric is. And this is often a very nuanced question. The North Star metric for a product really is about understanding the value received by customers, right? So you've got the customer, you've got the company. And in general, the customer provides money to the company in exchange for getting some type of value. At Udemy, a lot of that value is rooted in the learning that we provide, the learning experience that we provide, right? So understanding what that learning is super critical. And the North Star metric itself should be really a measure of value creation, not value capture. It is really a representation of the company's product strategy, or in the sense that what it is saying is that, the more of the value you deliver over time, the more money the company will be able to earn in the long run. Now, the reason the North Star metric is very useful is it really aligns everybody together around, what is the company trying to achieve? But that being said, in a company, often another challenge that will arise is people often wonder, like, well, okay, we have one metric that we want to optimize, but what are the metrics that best capture the user experience overall, right? So a framework that you can use for this is Google's HEART framework. So Google has a framework that talks about 5 main categories: happiness, engagement, adoption, retention, and task success. And these are main areas that help you understand, is a particular product design really working for users? Is it really helping users achieve their needs? These areas correspond to understanding user satisfaction, understanding to the extent to which users are really interacting with your product. Also, it gives you a sense of, like, how people are adopting the product, the retention. Are people sticking with the product over time? And are they really achieving their goals, right? So if you can use a framework like Google's HEART framework, it often simplifies the process of metrics creation, makes it easier to think about what it really means to build a great product. Another key idea often is the notion of activation points. These are sometimes called aha moments or magic moments. And activation points are really what happens when you take a North Star metric and you combine it with a threshold to understand an inflection point in the user's behavior. So often what you'll see is people want to know, what is it like? How do you know when a product becomes sticky for a user? Facebook, for example, has the popular metric 7 friends in 10 days. Once you reach 7 friends in 10 days, and that really is a point where maybe users actually become super sticky and will want to stick with the business for the long term, right? So the way that you actually end up doing this typically is to do some type of correlation analysis, but you'll also need to confirm it via experimentation. So you would look at behaviors that the user has during their first couple of weeks on a platform, and then see what behaviors are actually predictive of longer term behavior that you'd like to see from the customer. Another area that ends up being very useful is to understand concepts like funnels, segments, and cohorts, right? So funnels, segments, and cohorts, they're all pretty simple, and they're all kind of related. What funnels do is they really measure progress of a user through different stages of the customer journey. Segments break us down into subpopulations. It'll take a funnel, it'll say, like, well, A funnel is interesting, but I actually want to focus on a particular group of users for whom the product may be working better or worse. And the value that you get from using segments and funnels is funnels really give you a sense of what's working, what's not working. And segments allow you to compare across different user segments in order to understand why the product may be working for some users and not other users. There's also the notion of cohorts. Cohorts reveal heterogeneity in customer composition over time that can't be accounted for by measured characteristics. And so what this means is if you are looking at users who join at different periods in time, generally you would expect that maybe they ought to have kind of very similar behavior. But if you see fluctuations, that can give you a sense that perhaps the behavior that you're looking at is very time specific in some way. Then there's also another concept called attribution. So attribution is perhaps maybe theoretically questionable from a causal inference perspective. But attribution is this idea that many times when understanding a consumer journey, you'll look at how people interact with the website. And once they actually convert or perform a meaningful action in some way, conversion, you might want to be able to link that conversion back to something that occurred earlier in the journey as being the causal factor that drove that conversion, right? So now this is a little bit of a challenge from a causal inference perspective. There's not really a clear way to actually attribute causality in this sense. But nonetheless, in practice, attribution is very practically useful because it gives it provides many product teams with a way to understand what are the parts of the product experience that they should focus on and think about influencing as they iterate on their products. Another way of getting at causality is to do what's known as driver analysis. So in driver analysis, generally there's some outcome metric that you're interested in, and you're trying to understand what are the input factors that drive that output metric, and often people will use correlation. Now, of course, in statistics, we all know that correlation is not the same as causation, but in practice, it seems that people don't tend to care about that difference as much. One thing I will say is perhaps an interesting technique that you can consider using if you're performing a driver analysis is to use maybe slightly more advanced versions of driver analysis that focus not on correlation, but concepts like Granger causality. So Granger causality asks, can a particular input factor forecast future values of the outcome metric that you're interested in predicting while controlling for past values of that input metric, right? So when you put all these things together, Granger causality is somewhat similar to controlled regression, but it's slightly more powerful than correlation as a way of establishing causation. The final thing I'll also point out here is if you're entering the consumer product world, right? One thing that you absolutely need to be familiar with is real-world A/B testing. So A/B testing really is the gold standard for understanding what works and what doesn't work in a product. But with A/B testing, even though it is a controlled randomized experiment, there are a lot of nuances to getting it right. You've got to really think about a variety of problems that might come up when you're running a controlled experiment online. How do you handle bots, for example? How do you decide how to randomize users into your treatment group and your control group? What's the basis for that randomization? What are the different types of metrics that you should be optimizing? How do you deal with low statistical power? There are a litany of these types of questions that you need to consider in order to be effective in running A/B tests. And so as a consequence of all these, when you're entering the product testing world, I would definitely recommend looking at resources online. There's a great recent book that was published, Trustworthy Online Controlled Experiments, that lays out a lot of the techniques that you can use to be effective at A/B testing in practice. And so with that, let me provide some closing thoughts, right? I've outlined, the idea of product sense, product intuition, and a lot of product sense and product intuition is really about getting to know your customers, getting to know them well enough that you understand how do you solve problems for them. Then the data science side of this, the analytics side of this, is bringing techniques that might not all be based in rigorous causal experimentation, but nonetheless leverage data in some way in order to provide insight into, how customers are reacting to the product that you have today, and providing clues as to how you might evolve that experience over time. So to build a consumer web product, you really need to combine both kind of the art and the science. And one of the reasons I think it's super interesting, for me personally, is consumer products often attract a lot of users. With a lot of users, you have a lot of data, so you have this opportunity to combine this art and science effectively. And so, with that, thanks for your attention, and a reminder to everybody: always keep learning.
And let me take a look at the questions that have come in from the audience. Okay, Dr. Doe. No, Do. Did I pronounce it right? Doe.
It's Doe. Yeah.
Doe. Okay, okay, that's right. I thought I said Doe earlier. All right. Tom, what is the difference between, and forgive me for having to lean in because the print's a little small and I'm getting old, I guess. The difference between data science and data analysis. Is data analysis heavy on math and statistics too?
Yeah, great question. I think this is really a matter of opinion depending upon who you ask. So, in some companies, you'll see a distinction between data science and data analysis or data analytics. In those companies, they'll
Right.
often position data science as really around machine learning and AI, building the products directly, whereas data analysis is usually thought of as using data to understand some insight that then guides decision making. At other companies, though, data science really encompasses both of these areas, right? And in those types of companies, usually you hear data analytics considered uh, often called something like decision science. So, for at
Yeah.
Udemy, for example, we have a data science group that encompasses both decision science and data products. Philosophically, for me, the way I look at it is data science really is about using data effectively, no matter what you're doing, whether you're directly building the product or understanding how the product should be created. Decision science is just as important as the machine learning AI side. And so I consider all these things to be part of data science.
So the whole idea is whichever way you're looking at it, your data is driving your decision-making process, regardless of where it's coming from.
Yes, that's right.
There you go. All right. Well, I don't see any other. I don't see any other questions coming in. Again, Tom Doe, thank you so much for a wonderful presentation. I appreciate the insights that you've given, and I'm sure folks have been giving quite a bit to think about today.
All right.